What is Retrieval-Augmented Generation, or RAG, in LLMs? Hello everyone. Welcome back to the AI Tools Research channel. I'm Zeb Bhatti, your host. Large language models, or LLMs, have been in the forefront of this first wave of artificial intelligence adoption in the past 12 months. The most powerful applications derived from LLMs are generative text AI tools, such as chatbots. For example, ChatGPT and Bing are based on the GPT-4 LLMs. Bard is based on Palm and Gemini LLM. People who use these chatbots claim to be getting amazing productivity boosts from using these tools. But like all technology, LLMs have some drawbacks. Their drawbacks have to do with trust. The question arises from the fact that, can you always trust the answers they provide? If you ask someone who is a frequent user of chatbots, especially for serious and extended research, the answer you will get is a negative. You can't always trust the answers. While you can get some great results amazingly fast, there is also a fairly good chance that you will get some totally wrong answers. This is because LLMs generalize from data without being able to verify its accuracy or relevance. And sometimes it just gets it wrong. This video discusses the reasons for why large language models can give wrong answers and what can you do to avoid this problem. We'll discuss a solution, a framework, which can help large language models be more accurate and more up-to-date. This framework is called Retrieval-Augmented Generation, or RAG. Let's first talk about the generation part in this framework before we take on the retrieval-augmented portion. The term generation here refers to large language models that generate text or images in response to a user query, which is commonly referred to as a user prompt. In other words, the user prompts the LLM with a question and the LLM responds to this question. If you give the same prompt to different models, you may not get the same answer, or even the correct answer. And depending on the type of the model, the response to the user prompt can show a totally absurd behavior in some models. One model may generate fluent and coherent text on various topics and domains, but another may just make stuff up, even utterly nonsense. This is called hallucination. Hallucinations can be in form of prompt contradictions or factual contradictions. Factual contradictions, or factual error hallucinations, are really just straight-out facts that LLMs got wrong. For example, Donald Trump was the first president of the United States, something like that. The most common type of hallucinations are nonsensical or irrelevant kind of information-based hallucinations where the model just outputs something that really has no place being there. For example, the son of a king is called a prince, and the model also just outputs, Prince is also the name of a famous singer. So why do LLMs hallucinate? There are several reasons for this. The first, of course, has to do with the poor training and generation methods employed in training and inference. The term inference refers to the process of using a trained model to generate an output or prediction based on a given input. LLMs use various methods and objectives to generate text such as beam search, sampling, maximum likelihood estimation, or reinforcement learning. Some models are not trained using the best methods in order to save costs in the training and inference. The next reason for erroneous output can be the input context, and this is one we can do something directly about as users. The term context here refers to the information that is given to the model as an input prompt. Context can help guide the model to produce the relevant and accurate output because without context, the model gets confused and misled. When the model is confused, its response can be unclear, inconsistent, or contradictory. We have some other reasons that can be the cause of hallucinations, and they have to do with certain model parameters settings, like size of the context window and temperature parameters. Both these affect the hallucination of a large language model. The context window determines the amount of text the model considers when generating responses. A larger context window provides a broader context. However, exceeding the context window can lead to coherence problems leading to hallucinations in the LLM's output. The temperature parameter controls the randomness of the LLM's output. The temperature parameter is a hyperparameter that controls the creativity and diversity of the generated text. It adjusts the probability distribution of word selection, influencing the model's behavior and creativity. Basically, a high temperature parameter value leads to more creative and imaginative text but is more prone to hallucination. And a low value results in more accurate and factual text, but can potentially make the output boring and repetitive. To fix this, we can employ something called active mitigation strategies and tweak both parameters and balancing the precision and generalization of the LLM's output. This fine-tuning can help minimize hallucinations and inaccuracies. One thing to note is that tweaking the size of the context window is complicated as it affects many other things like inference costs and response time. Finally, and the most common reason for hallucinations in LLMs is the quality of the data that the model was trained on. LLMs are trained on a large corpora of text, images, and code that may contain errors, biases, or inconsistencies. In other words, the data is somewhat contaminated and noisy. This happens when the training data is scraped from the web, Wikipedia, and all of Reddit, etc., and not cleaned properly to remove errors, duplicates, and inconsistencies, among other things. Some of the data may be obsolete, incomplete, factually incorrect, and not 100% accurate. But how can we fix the problem of poor, incomplete, and outdated training data? How can we resolve the issues relating to absence of important and relevant stuff in the corpus that was used in model training? This is extremely critical where an LLM is being used for research and both the absence of key data and the reliability of sources of the provided data matters. It is absolutely necessary in research outcomes to have accurate data from authenticated sources to support the research. You just can't have an unverified source and rely on answers off the top of your head. The problem of out-of-date answers and problems related to information sources are two challenges in interacting with LLMs. This is where Retrieval-Augmented Generation, or RAG, comes in, to make the model's output and answers more grounded and believable. The purpose of retrieval augmentation is to have the large language model confidently access the most current data from verified and authenticated sources. How does RAG work, and how is this done without retraining the entire model? Well, we create a means for the LLM to look up additional sources instead of just relying on what the LLM has been trained on and knows. In other words, we augment the model's information base and add an additional content store for it to grab information from. This could be the open internet. This can be a collection of research documents, a set of books on policy and facts, and any other relevant material, etc. In Retrieval-Augmented Generation, the LLM first goes and talks to the content store and says, "Can you retrieve this information for me that is relevant to what the user has asked?" In a traditional LLM prompt, the user prompts the LLM with their question, and the LLM responds from its learned data. We basically just talk to a generative model, and the generative model gets a response. But in the RAG framework, the generative model actually has an instruction that says, first, go and retrieve relevant content. Combine that with the user's question and only then generate the answer. So the prompt now has three parts: the instruction to pay attention to, combine that with the user's question, and retrieve the content to fully answer the user's question. With this, the model can give evidence for why its response was what it was. So now hopefully you can see how RAG helps fix the two LLM problems we mentioned. You do not require retraining your model with new information that comes up. All you have to do is you augment your data store with new updated information. So now the next time that a user comes and asks the question, the LLM would have the latest data. We just go ahead and retrieve the most up-to-date information. The second problem is source of the data. Well, the large language model is now being instructed to pay attention to the primary source data before giving its response, and in fact, is now able to give evidence of the source. This makes it less likely to hallucinate or to leak data because it is less likely to rely only on information that it learned during training only. It also allows us to get the model to have a behavior that can be very positive, which is knowing when to say, "I don't know." If the user's question cannot be reliably answered based on your data store, the model should say, "I don't know," instead of making up something that is believable and may mislead the user. It is better and safer for a large language model to give the best and most high-quality grounding information than mislead users with wrong answers. Corporations can immensely benefit from RAGs as they have a lot of proprietary and valuable data that is not publicly available and now can be merged with the model's training. This can give them a huge competitive advantage without incurring training costs that require massive compute power. A lot of effort is being directed towards both working to improve the retriever to give the large language model the best quality data on which to ground its response, and also the generative part so that the LLM can give the richest and best response to the user when it generates the answer. Thank you for watching. We hope you found the video valuable. If you liked it and want to see more content like this, please subscribe to our channel and don't forget to press the like button. We hope to see you again soon.